Here's my very last video, example number 3 of A not 1. And we are going to do the same process of what we had been doing before. We're going to graph from standard form by finding the vertex and by factoring and quadratic formula. You're going to see something unique happen with this one here, but I'm going to start the process the same way. Okay, to find the center of your picture, we're going to use our axis of symmetry formula, which is opposite b over 2a. And your 10 is positive, the opposite of that b term, again, a, b, and c respectively in your formula, if it's in standard form. Opposite of positive 10 is negative 10. Double A for the bottom, 2 times 5 is going to be in the denominator, 2 times A. And negative 10 divided by 10 will get me negative 1. So my axis of symmetry and my vertex will land at negative 1 comma somewhere. Okay, so here's my marker. My center line will be negative 1. Axis of symmetry, negative 1. Okay, now how I'm going to find out where my vertex lands on this point is by plugging in the number negative 1 into my function. So here we go. 5x squared plus 10x plus 5. Where you see an x, you need to use parentheses when you plug in your number negative 1. So here we go. Clear out what I had. 5 times, I'm going to substitute in negative 1 for x and square it, plus 10 times my x coordinate, which is, again, I'm plugging in negative 1, and then minus 5. I'm going to get out the number negative 10. So all the way down at the bottom here. Now, this is not going to follow my normal pattern because my A of 5 is going to alter that pattern. So I'm going to show you with a table and then this pattern as well. So here's going to be my table, x comma y. Okay, my vertex was at negative 1, negative 10. Okay, so that's my center. If negative 1 is the center, then to the right would be 0, and then 1 and 2. To the left of my center would be negative 2 and negative 3 and negative 4. And just like I plugged in negative 1, I'm going to plug in each of these numbers in my table. I'm going to start with negative 4. And I get 35. That's going to be way off my paper. It's okay, I just won't be plotting that point. Plug in negative 3. This is 10. Plug in negative 2. I get negative 5. I already did negative 1, so now I'm going to delete my negatives. So delete that one, and now change these 2's to be 0. I'm plugging in the number 0 next. That should be negative 5. Notice how this mirrors. It should be symmetric, so I'm expecting for my next answer to be 10 to mirror the next one here. So if I plug in 1, I should get the number, yes, 10. And now if I plug in 3 away to the left, 3 away to the right from the center, I should get the same number when I plug in 2 as when I plugged in 3 away to the left, negative 4. I should also get 35. Now you might be curious, oh, I noticed that the pattern wasn't the same this time. And if you notice that, that's a really good thing to notice. It does not go in this case from your vertex up the same amount. So out 1, up 1, out 2, up 4, out 3, up 9, out 4, up 16. If you were paying attention in the last video, your A is going to alter that pattern. So my A in this question is 5, which means it's going to go 5 times the normal amount. So if my A is 5, I'm going to take 5 times 1, which means my first move is going to be up 5. And you'll notice from negative 10 to negative 5, 0, 1, 2, 3, 4, 5, it does go from my vertex up 5 right away. My second move isn't going to be normally up 4, it's going to go 5 times 4, which is going to be up 20. So A times this pattern, and A, my 5 times 9 would be up 45, And 5 times 16, goodness, I don't have that memorized. That's up 80. So it goes 5 times as fast as the normal rate. So as I plot my points here, you're going to see this pattern emerge, A times the pattern. So I'm going to plot these points that I don't have on my grid here. -1, -10 was my center. Here's -2, -5, and 0, -5. Here would be 1, 10. Here would be -3, 10. And I can't graph 35. It's just way too far off my grid. But this goes up 5 times the normal pattern. So you'll see that show up here. From -10 to 35, that is up a movement of 45. Now I didn't plug in 3, but you would see it's going to go from -10 up 80, which should get you, go ahead, you check it, should get you the number 70, and that should match if you plug in -5, it should go up 70. Okay, now I'm going to show you how to get these two x-intercepts because it doesn't look like it lands nicely on my picture. Okay, now, when I know it doesn't land nicely because of my picture, that can help give me an idea for factoring. But I'm going to connect these two now to solve for our x-intercepts. I also don't have any numbers over on the y column of my list that say 0, which means it's going to be in between here. In between -5 and 10 is 0, so I am expecting my intercept to be somewhere in between -2 and 3, and here in between 0 and 1. So I'll show you with factoring here. Okay, if you have 5x squared plus 10x minus 5 for the function, what I start with is telling myself, well, if I have 5x squared, because 5x is prime, my only possible combinations to get that would be 5x squared. And to multiply to get -5, my only possible combinations are 5 and -1, or a -5 and a +1. Now I taught my class to start with getting some ideas going down here. A times C, I put at the top of my big X, which would be -25. 10, your B term goes at the bottom. Can you think of any two numbers that multiply to make -25? You need a negative and a positive that will add to make 10. I'm telling you, you can start thinking all day. It's not going to work. You can try all these possibilities. It's just not going to work. This is not factorable. And so I'm going to prove it to you with my quadratic formula, how I also know that. You might be thinking, well, Miss Devely's 5 and 5, but my signs, in order to multiply to get a negative, one has to be negative and one has to be positive. So it's impossible to get a 5 and a 5 to add to make 10 if one has to be positive and one has to be negative. I'm going to show you how I also know it's not factorable with my quad form, and now I'm actually going to solve for those decimal locations here. Okay, x equals, my x-intercepts are opposite sign of my b, should be -10, plus and minus the square root of b squared. B squared, 10 times 10 is 100. Then I'm going to take the number 4 times my number a, which is the 5, times the c number, which is -5. All of that will get divided by double my a term, in this case, double 5. Okay, 4 times 5 times 5, well, it's actually times -5, is going to be -10 plus and minus the square root of 100 minus -100. And 2 times 5 for the denominator there, I'm going to put 10. Well, two negatives are going to cancel out and make that a plus. We're going to be adding. So -10 plus and minus the square root of 200 all over 10. Now I'm going to have you grab your calculator. If your teacher asked you to do exact, you would find the perfect square that goes into 200, which will end up being 100 times 2. I'll show you both since I have time. Square root of 100, if you're asked to find the exact answer, would be 10 radical 2. Now if you simplify in exact, your outside numbers I notice are all 10. They're all divisible by 10. So if you have a calculator that will simplify exact for you, you would see something like this. And now let's grab our calculator and I'll show you how to type this out. And we'll get our decimals. We want -1 plus the square root of 2. You want to hit enter. I don't need to divide by 1. That's fine. And if this part, simplifying the radicals, seems too confusing to you, you can jump back up and I'll show you. You'll get the same decimal from here. Okay, I'll show you both. And then I'm going to get one answer from when I do this subtraction, -1 minus the square root of 2. Watch from here to here. So if simplifying radicals it isn't making sense to you, you can get your decimal answers from here. I'll show you, you'll get the same answers, one for addition, one for subtraction, okay? -1 plus the square root of 2 will get you this decimal. Looks pretty accurate on my picture, 0.414. Okay, I'll do a few decimals so we can compare. Now if I did my addition up here, this would be -10 plus the square root of 200. Now I have to hit enter before I divide by that 10 in the denominator. Notice how I got the exact same decimal when I did my adding here and adding here when I simplified my fraction. So 0.414. And that's what I was expecting, something in between 0 and 1 because it went from -5 to +10. So it has to cross 0 somewhere in the middle there. Okay, now I'm going to get my second solution. It looks like it's going to be in between -2 and -3. That's what I'm anticipating. So -10 minus the square root of 200. Again, you have to hit enter for the numerator and then divide by 10. I get -2.414. I should get the same thing for when I had simplified my fraction. -1 minus the square root of 2. Notice how I got the exact same answer, -2.414, which is about exactly where I had been thinking, in between -2 and 3. This is our lesson today. We were comparing our graphs when we had found the center, the vertex first, compared to factoring and quadratic. And if you watch my other videos, we did 3 of these. I hope that makes connections between standard form and finding your vertex form first versus solving for your x-intercepts with factoring and quadratic formula. Your x-intercepts are also called your solutions, your roots, your zeros, because you set your function equal to 0 to find your x-intercepts. I hope that kind of connects the things we've been learning today. Next, what you guys are going to do is work on an activity in your groups. It's called 4 forms. Good luck, and I'll see you next class.